Hi everyone, Miss Caulfield here. In today's video, we are going to be looking at special types of ions known as polyatomic ions, as well as expanding on naming ionic compounds to include those polyatomic ions in them. Previously, we have talked about binary naming. Remember that prefix bi means two, and so in binary ionic compounds, we're looking at just two elements. But it is possible for compounds to exist that have more than two elements in them, and that's what the focus of today's video is going to be on, is how do we write formulas for those types of compounds. So like I previously said, it is possible for ionic compounds to have more than just two elements in them. When an ionic compound that has more than two elements in it, we refer to those compounds as ternary compounds, as we see here in red and underlined. These compounds consist of special kinds of ions known as polyatomic ions. Your friends may have warned you about these in chemistry class if they've taken chemistry before, but I promise they're not that bad. Polyatomic, let's break that word down. So that prefix poly means many or more than one, and atomic is referring to atoms. So a polyatomic ion is going to have more than one atom in its ion form. There are a lot of different polyatomic ions that exist, but in this class, we're only asking you to memorize 10 of the most common ones, and those are going to be the 10 that we look at next. So here is a list of 10 of the more common polyatomic ions. I want you guys to go ahead and take a few minutes to write these down on a separate piece of paper. You can pause the video here. I would also recommend maybe making flashcards or a Quizlet for these because you are responsible for knowing the formula for these 10 polyatomic ions as well as the name for each of these polyatomic ions. There is something helpful on YouTube. If you are more of a visual learner, you can check out a YouTube video called Nick the Camel. If you search Nick the Camel and polyatomic ions, it will pop up, and that is another way to help you memorize a couple of these formulas. So as we write these down, let's take a look at these charges. So we see in nitrate, we have a polyatomic ion of NO3, 1 minus. Sulfate has a formula of SO4, 2 minus. Chlorate has a formula of ClO3, 1 minus. And all the way down to ammonium with a formula of NH4 plus. So when we take a look at these polyatomic ions, would we say that polyatomic ions are generally cations or anions? Well, when we take a look at the formulas, we would say that they are generally anions because they are mostly negatively charged, with the exception of ammonium. So like I just said, polyatomic ions are generally anions. There is an exception to that with the common polyatomic ion called ammonium, which is NH4. This is slightly different than a compound called ammonia, which has a formula of NH3. Because they have different formulas, they do have slightly different names. When we are writing formulas, writing the names of compounds, ternary compounds that include polyatomic ions, we're going to follow the similar rules to what we looked at for binary naming. So the cation always comes first. And then the anion will come second. But the big thing with the anion, which most of the time in ternary naming will be your poly, instead of changing the ending of the polyatomic ion's name to "ide," we are not going to change it. Do not change the ending to "ide." You're going to just keep it as the polyatomic ion's name. So when we take a look at this chemical here, we've got NaNO3. Our cation is sodium because sodium has a +1 charge. And then when we look at our list of polyatomic ions that hopefully you wrote down somewhere, we would see that that NO3 ion is known as nitrate. So we would write this down as sodium nitrate. Again, you do not change the ending of the poly. It stays as it is. So just to familiarize you with a little bit more with these polyatomic ions, let's go ahead and take a minute and match the following names with their correct formula. Well, when we take a look at barium sulfate, we know barium has the chemical symbol Ba, and sulfate has the formula of SO4 2-. So barium sulfate is going to be this last one down here. When we take a look at potassium chlorate, we know potassium has the symbol K, and chlorate is ClO3-, so it would be directly across from it. Looking at our next one, lithium hydroxide, we know lithium symbol is Li, and hydroxide has the formula OH-, so we're looking at this top one here. Looking at the next one, ammonium chloride. So ammonium is the cation, which is why it comes first in the formula and in the name. And so we're looking for ammonium as the first element in the formula, followed by a chlorine ion, because that "ide" tells us it's just the element, not the poly. That IDE tells us that it's just the element, not the poly. So we're looking at this third one here of NH4Cl. And then that leaves us with our last one, a sodium phosphate. We know sodium has the element symbol Na, and phosphate has the formula of PO4 3-. So we're looking at this fourth one in our list. So now that we've had the chance to take a look at how we would write the chemical name based on the ternary ionic compounds formula, we're going to take a look at the reverse and learn how to write the formula based on the name. Well, when we're writing the formulas for ternary compounds, we're going to follow the same steps that we followed when we were writing the formula for a binary compound. We're still going to use this swap and drop method. The only difference here is that in ternary compounds, we are going to be swapping and dropping the charges of the polyatomic ion, which means that we may have to use some parentheses in our formula. And we'll take a look at examples of where you do need to have a parentheses versus where you may not need to have one. So let's start by looking at an easy one. We're going to take a look at this first one over here of sodium cyanide. So the first thing we're going to do is find the element on the periodic table. For sodium, we'll write that element symbol down and the charge that is associated with that element. So above sodium, we know that elements in group 1 have a +1 charge, which is why we see Na +1 here on the screen. Looking at our list of polyatomic ions, we know that the formula for cyanide is Cn, both capitalized, with a charge of -1. So we swap those charges and we get Na1Cn1. And then when we combine those two symbols together, remember you're going to get rid of the ones because we never write a 1 in a chemical formula. Let's take a look at number 2. So in number 2, we're looking at lithium sulfate. So we'll find lithium on the periodic table. Lithium is also in group 1, so we see that it has a +1 charge. And then taking a look at our list of polys, we see that sulfate has a formula of SO4 3- as its charge. So we will swap those charges, and we see that this 3 becomes the subscript for lithium, and that the 1 becomes the subscript for the whole sulfate ion. So here is where you don't actually need to include the parentheses, but I highly encourage you to put your polyatomic ions in parentheses because it's going to help make sure that your formula is correct. So when we take a look at our final formula, notice we did get rid of the 1. So having the parentheses here is optional, but it doesn't hurt to include them in your formula. Let's take a look at where we would have to include the parentheses, and that's going to be in our last example here, where we're looking at ammonium carbonate. So when we look at the formula for ammonium on our list of polyatomic ions, we see that it has the formula of NH4 +1. Carbonate has the formula of CO3 2-. So when we swap those charges, that 2 is going to become the subscript for the ammonium, as a whole, and the 1 is going to become the subscript for the carbonate. Well, since we just need 1 carbonate, we don't need to include parentheses around the CO3 part of the formula, unless you want to. It doesn't hurt to include them. But since we have we need 2 ammonium polyatomic ions in our formula, we have to include the parentheses in the final formula, which is what we see here. We see the parentheses surrounding that ammonium polyatomic ion, saying that we need 2 ammonium ions for every 1 carbonate. So here we've got 2 more practice problems that we're going to work through together, and then you'll try one on your own. So again, the first step is identifying the different elements in the formula. So we know sodium has an element symbol of Na, and when we look on the periodic table, we see that it has a +1 charge. Hydroxide is one of our polyatomic ions. When we look at our list of polys, we see that hydroxide's formula is OH -1. So when we swap and drop those charges, we get Na1, OH1. Again, remember, those charges are going to become the subscripts for the opposite ion. And then when we combine those, we're going to get rid of the 1s. So here you could leave the OH in parentheses, or you could not have the parentheses, and either of those would be considered correct because you just need 1 of the hydroxide ions in the formula. All right, let's take a look at a little more challenging one. So aluminum acetate. When we look on the periodic table, we see that the symbol for aluminum is Al, and that aluminum has a charge of 3+. When we look at our list of polyatomic ions, we see the formula for acetate is C2H3O2 -1. When we crisscross those charges, we see that the 1 is going to become the subscript for the aluminum, so we'll have Al1, and that the 3 is going to become the subscript for our acetate. So we're going to want to go ahead and put that acetate into parentheses because we need more than 1 acetate in our formula. And then lastly, when we combine them together, our final formula would be Al, and then in parentheses, C2H3O2, 3. So since we need more than 1 of the polyatomic ions, we need to have parentheses around the poly. So parentheses are needed when the subscript for the polyatomic ion is not 1. So anytime we have a subscript that is not 1, we want to make sure that we have parentheses around our polyatomic ion, which is why it's okay if you want to go ahead and just practice putting your polys in parentheses. It doesn't make the formula wrong. So that is just one good fail-safe way of making sure that you're writing your formulas correctly. But if you don't want to include them, you don't have to unless you have more than 1 poly in the formula. All right, so now I want you guys to go ahead and finish up by writing the formula for magnesium chlorate. So we'd follow the same steps for writing this formula. Magnesium has a charge of +2. Chlorate has the formula of ClO3 1-. When we crisscross those charges, we get Mg, and then in parentheses, ClO3 2. Mg1, ClO3 2, and then when we combine them together, we get Mg, ClO3 2 as our final formula.